Hi gang, let's work out number 8 from packet 7. This one's an identity. You want to make the left side look like the right side without moving anything across the equal sign. So to say that another way, you basically want to modify this to look like that. So the first thing you might notice is that on the left there's a fraction, there's 2 fractions. And on the right, let me say that even better. On the left side, there's 2 terms, and on the right side, there's 1 term. So the first thought that might come to your head is that I have to convert 2 terms into 1 term. So if you have fractions, how would you do that? How would you convert these 2 terms into 1 term? All right, so that would be by getting the LCD, right, to combine the fractions. So the LCD here is going to be cosine theta, sine theta. Okay, so we'll just go ahead and balance these fractions. All right, so we'll give a cosine to each side here and a sine to each side here. Okay, and then when we do that, we'll have sine squared theta on top, because that's the sine times the sine, that's sine squared. And we'll have the cosine times the cosine, that's cosine squared. Okay, so when we get the LCD, this becomes sine squared plus cosine squared. All right, now can you think of an identity that is equal to this? All right, if you remember, we have the Pythagorean identity. The Pythagorean identity for sine and cosine says sine squared of theta plus cosine squared of theta equals 1. That's your Pythagorean identity. There's 3 of them. So over here, we can replace this with 1. And it'll look like that. Okay, now we're not quite there yet, right? We want to make the left side look like the right, so I want to keep this the same on the right side. So now let's think of another identity we might be able to use here. I can reformat this if it's a little easier for you to think about. This would be equivalent to me saying this. Okay, so if we do that, can you think about what identity we might use here? Good, the reciprocal identity, right? So the reciprocal identity says that cosecant of theta is equal to 1 over the sine of theta, right? That's the reciprocal identity. So I can replace this with cosecant of theta. And likewise, secant of theta equals to 1 over the cosine of theta. So I can replace this with secant of theta. So now you can see that I've made the left side look like the right side, and therefore we've finished proving that this is indeed equivalent to that by using our identities. There's a couple of these exercises in the book, and they're just fun ways to practice. Let me say that a little better. It's just fun ways to help you memorize the identities. Okay, gang, I hope that helps. I'll catch you in another video. Bye-bye.